In this video, we're going to go over derivatives of polynomials and exponential functions, more so at the beginner level. So let's dive into some examples. Y is equal to x to the power of 5. To take the derivative of this function, we simply take the exponent, put it down in front, and then minus 1 from the exponent. So we are left with dy dx is equal to 5x to the power of 4. Similarly with this example, multiply by the exponent, subtract 1 from the exponent, dy dx is equal to 12x to the power of 11. Here we have f of x is equal to negative 4x to the 9. So when we take the derivative, write this down as f prime of x is equal to negative 4 multiplied by the exponent, and then minus 1 from the exponent. And then we are left with negative 36 x to the 8. Here y is equal to minus 7 x to the 6. Take the derivative, dy dx is equal to minus 7 multiplied by the exponent, minus 1 from the exponent. We have minus 42 x to the 5. Y is equal to 5x to the 4 minus 3 pi. If we take the derivative of this, we simply just take the derivative of each individually. So the derivative of the first one, we have 5 times the exponent, minus 1 from the exponent, and the derivative of 3 pi is just a constant, and the derivative of any constant is just 0. Then we are left with dy over dx is equal to 20x cubed. Here we have s equals 3t to the 4 plus 4t minus 8 over t squared. So first, we're going to rewrite this so everything is on the top. And then it's going to be minus 8 t to the minus 2. And now we can just take the derivative of each side. So here, since we have s and t, we're going to write ds over dt is equal to 3 multiplied by the exponent, and then minus 1 from the exponent. And then we do this again to the next one. We have 4, the exponent is 1, and t is written to the exponent 1, minus 1, minus 8, multiplied by the exponent is negative 2, then it's t to the minus 2, minus 1. So we simplify this all up. We have 12t cubed plus 4t to the 0 is just equal to 1, so we just have 4, and then minus 8 times minus 2 is positive 16, t to the minus 3, and then we can rewrite this with no negative exponents. And there's our final answer. Okay, y is equal to x squared plus 2x. Take the derivative, dy over dx is equal to, take the exponent down front, minus 1 from the exponent. Do the same for the next one, where we just have 2 times 1, x to the 1 minus 1. So we can rewrite this as dy over dx is equal to 2x to the 1, and we don't have to write the 1, plus 2 times x to the 0, which is just going to be 1, so it's just going to be 2. And there's our final answer. y is equal to 3 cubed minus 2 over 3 x squared. Taking the derivative, dy over dx is equal to, multiply by the power, minus 1 from the power. Simply do the same on, on this side. Multiply by the power, minus 1 from the power here. These 2's cancel out. Then we are left with dy dx is equal to 3x squared minus 3x. And if we wish, we can factor this out to simplify. Dy dx is equal to 3x x minus 1. There we have our final answer, but both of these should be sufficient. P is equal to 5r cubed minus 2r plus 1. So here we're going to take the derivative of p with respect to r. So we're going to write dp over dr. And then we just do the same. 5 multiplied by the exponent, minus 1 from the exponent. And then 2, the derivative of r is just going to be 1. And then the derivative of a constant is just going to be 0. Then we just simplify this up. And there we have it. Y is equal to 6x squared minus 6x plus 5. Taking the derivative, we have dy over dx is equal to 6 multiplied by the exponent, minus 1 from the exponent. Then 6x, the derivative of x is just 1, so we're going to be left with 6. And then the derivative of 5 is just 0 because it's a constant. Simplifying this up, we have 12x minus 6. And if we really wanted to simplify this further, dy over dx, we could factor out a 6. We have 2x minus 1. Either of these should be good. Y is equal to 25x to the 8 minus 34x to the 5 minus square root of x. So let's rewrite this with the square root as an exponent. Y is equal to 25x to the 8 minus 34x to the 5 minus x to the power of 1/2. Now we take the derivative, dy over dx is equal to 25 times the exponent, minus 1 from the exponent, minus 34 times the exponent, x to the 5 minus 1 from the exponent, and then we have minus, multiply by the exponent, which is 1/2. Then we have x to the 1/2 minus 1. And then if we change this 1 into a fraction, this is going to be 2 over 2. Now we simplify this all up. We have dy over dx is equal to 200 x to the 7 minus 170 x to the 4 minus 1 over 2 x to the minus 1 over 2. Now if we rewrite this all with positive exponents, we will have dy dx is equal to 200 x to the 7 minus 170 x to the 4. We're going to have minus 1 over 2 square root x. Because when we simplify this, we will have 1 over 2 x to the minus or plus 1/2. And then this will just simplify to 1 over 2 x to the square root. So this here is our final answer. Okay, u is equal to 4v to the 4 minus 12v plus 9. Here we have u and v. So we are going to take the derivative of u with respect to v. So we write this as du over dv is equal to 4 multiplied by the exponent minus 1 by the exponent minus 12. The derivative of v is just going to be 1. And then the derivative of a constant is 0. Simplifying this, we have du dv is equal to 16v cubed. Here we have a function of x, which is equal to minus 6x to the 7 plus 5x cubed plus pi squared. When we take the derivative of a function of x, we can write this as f prime of x, indicating the derivative, is equal to, and then we follow our normal rules, minus 6 multiplied by the exponent, minus 1 from the exponent, plus 5 multiplied by the exponent 3, x to the 3 minus 1, plus the derivative of pi squared is just a constant, it's just a number, and this is going to be 0. Simplifying this up, we have f prime of x is equal to minus 42 x to the 6 plus 15 x squared. And this is our final answer. Y is equal to 13 x to the 4 minus 6x cubed minus x squared. Let's take the derivative of this. We have dy over dx is equal to 13 multiplied by the exponent, x to the 4 minus 1 from the exponent, minus 6 multiplying by the exponent, x to the 3 minus 1, minus the derivative of x is just going to be 1, so we have minus 1. Then same thing here, we have x squared multiplied by the exponent, we have x 2 minus 1. Simplifying this up, we have dy over dx is equal to 52 x cubed minus 18 x squared minus 1 minus 2 x to the 1. Then we could rearrange this so that the order is a bit better. dy over dx is equal to 52 x cubed minus 18 x squared minus 2x minus 1. We're simply just switching these to follow the order of the polynomials. And that is our final answer. Here we have some fractions, but we're going to follow the exact same principle. We take the derivative, we have dy over dx is equal to 1 over 3 multiplied by the exponent 3, x cubed minus 1 from the exponent, plus 1 over 2 multiplying by the exponent of 2, x squared minus 1 from the exponent, minus, and then if we think about this one here, this is going to be x to the minus 1. If we take the derivative of that, we multiply by the exponent minus 1, and then we minus 1 from the exponent. Then rewriting this out and simplifying, dy over dx is equal to, these 3's cancel out, we just have x squared plus these 2's cancel out here, and then we have x to the power of 1, which we don't need to write, and then over here we have minus minus become a plus, so we're going to plus x to the minus 1 is going to be negative 2, and we can rewrite this with no negative exponents as dy dx is equal to x squared plus x plus 1 over x squared. That is our final answer.